Okay, so we have turned up the recording, and because I'm having pan, so you'll be hearing some chewing sound. Disregard that. So class we have seen up till the idea of the conservation of linear momentum. The entire point of this equation was that whenever in an enclosed system means whenever two colliding objects only exert force onto each other, there are no secondary source of force. So that's what we mean by a closed system. So within a closed system, the total momentum before collision would basically equal as the total momentum of the objects after collision. So m1v1 plus m2u2 equals to m1v1 plus m3v3. This was the generic equation that we have had. যদি কোনো একটা সার্টেন কলিশনে যদি তোমার মাল্টিপল অবজেক্টস সাইমালটেনিয়াসলি কলাইড করে, ফর এক্সাম্পল if you had three objects which collide with them simultaneously, linear direction actually সেটা হওয়া খুব difficult, but in that case this can also have another part. For example, m1v1 plus m2u2 plus m3u3 equals to m1v1 plus m2v2 plus m3v3. So this equation does not essentially require four terms. Depending upon the number of bodies involved, we can have other components on the left side and other components on the right side as well. That is also possible. এটা এই ধরনের কোশ্চেন ইউজুয়ালি হয় না, বাট জাস্ট আমি কনক্লুসিভনেসের জন্য পুরোটা বলে দিলাম। নেক্সট উই আর গোনা সি দিস পার্ট। এখানে খেয়াল করো, u1 u2 v1 and v2 are all vectors. Be very careful to choose their signs in equation from the question, যেটা আমি লাস্ট ক্লাসে অল্প একটু বলছিলাম। In any collisions, total momentum is conserved, total energy is conserved, where kinetic energy might not be conserved. This is an important bit. So in any collision, এটা অবশ্যই কনজার্ভ হতে হবে, এটা অবশ্যই কনজার্ভ হতে হবে। কাইনেটিক এনার্জি মাইট অর মাইট নট বি কনজার্ভ। আচ্ছা, এখানে এই মাইট ওয়ান্ডার যে টোটাল এনার্জি কি সবসময় কনজার্ভ হবে? একটা কেসে টোটাল এনার্জি সবসময় কনজার্ভ হবে না, সেই একটা কেস হচ্ছে নিউক্লিয়ার কেসেস। If you have some collision of particles that lead to nuclear fusion, because মনে করো দুইটা হাই স্পিড হাইড্রোজেন পার্টিকেলের সাথে জয়েন হয়ে একটা হিলিয়াম নিউক্লিয়াস প্রডিউস করতেছে, সো ওই ধরনের কেসগুলো যদি হয় তাহলে সেই কেসে আমাদের এনার্জি কনভার্সন হবে না, বিকজ in nuclear scenarios we have mass and energy interconvertible. But for non-nuclear cases, or which I mean that macro cases, always mass is a conserved quantity and energy is also a conserved quantity. But for nuclear cases, energy and mass are not independently conserved quantity, they are combinedly conserved quantity. This is something that we will also see in the nuclear physics chapter or radioactivity chapter, somewhat at the end of the quite at the close to the end of the syllabus. So point being, total momentum is conserved in any collision, total energy will be also conserved, whereas kinetic energy might be conserved, might not be conserved. One of the very simple example for this statement, let me give you two simple examples so that it can make sense to you, is that let's say you are dropping a tennis ball onto the ground. As you let go of the ball is going to fall downwards by a certain height and it will hit the ground and then bounce up backwards. Now what you need to understand that because the earth is a very massive object, so essentially the earth is not going to move pretty much for this collision. So pretty much the only movement which will be observed is available for the tennis ball. But for any regular case, we'll see that the tennis ball after the first bounce does not rise up to the same height, which means the tennis ball does not rise up to the same height, which means that the height of the ball where you did drop it from would be somewhat bigger compared to the first maximum height after the first bounce. This essentially means that initially the amount of GP that initially got converted into K as the ball fell through the height after releasing, that GP converted to K, and as the ball touches the ground, the GP conversion is over, and then it will have collision. Inside the collision we'll have the process of compression and decompression. Decompression because I'm saying decompression because that's not essentially expansion, because the ball never gets bigger than its original size. For the part of the squashing, it becomes somewhat smaller and then it gets back to its original shape because of elastic properties, and ultimately it bounces up. Within this process of collision, of this squashing and de-squashing or compression and decompression, the object, some of the object's kinetic energy would be converted into heat and sound. Now heat is a default output, it will always be there. Sound might be there, might not be there. You might, if you feel like that might not be there, cano. If you feel like that, why it might not be there? One of the reasons is that we human beings can hear sounds for a certain amount of frequency, which we call the audible range. We can hear frequencies from 20 hertz up to 20,000 hertz. For a regular human being, that's about the range of audible frequency. So which means that whenever the ball will hit the ground, it will essentially vibrate itself, and it will also vibrate the ground as well. So that vibration might dissipate through the surrounding. Whenever we use our surrounding, we don't essentially mean exclusively ground. Surrounding would mean ground plus atmosphere. Now, if the frequency of the vibration is somewhat lower than 20 hertz, then you will never be able to hear that. If the frequency of the vibration is somewhat bigger than 20 hertz, then you will definitely hear that. Simple example, let's say you drop a rubber ball, solid rubber ball, from about half a meter height. Whenever it will bounce back, it will not reach to its original height, but you wouldn't be able to hear the sound, because rubber, being a very highly what can I say, a highly flexible material, let's use that term, it does not produce a vibration that is more than 20 hertz. It produces an infrasonic vibration, so we cannot hear that. Whereas if you drop let's say a bowling ball or a golf ball, or let's say another hard object can be the billiard balls, which are extremely hard, that is going to give you a very large sound, because their surfaces are hard, their vibration would have a much higher frequency. As a result, my point being that sound might be heard, might not be heard, depends on how much frequency that collision provide, but heat will always be produced. So some of the kinetic energy of the collision would be essentially converted into heat energy in any real case collisions. I'm using the word real case to represent that this is going to happen for all practical scenarios. For hypothetical cases, or for very, very rare scenarios, we can disregard the generation of heat energy. There are some very few examples of that, which I'm going to discuss a bit later. So the point that I want you to get in your head is that during the collision in this scenario, some kinetic energy, portion of a kinetic energy is converting to heat energy and dissipated out. As a result, the instance the ball after completing its compression and decompression, as the ball leaves off the ground, the instant where the ball loses its contact with the ground, it does not have the same amount of kinetic energy as it started with. So it definitely rises up to a smaller height. With every subsequent bounces, that keeps on happening, and eventually the ball can lose all of its energy, and that would be essentially transferred to the ground and to the atmosphere. Energy cannot be created or destroyed, so that energy simply didn't vanish. It just transferred from the ball to the other objects, in this case, namely ground and atmosphere. So this is an example where after every collision, the total amount of kinetic energy is less compared to the total amount of initial energy. That's one type of example. The second type of example is the case where your final kinetic energy might be somewhat bigger than your initial kinetic energy. One of the simple ways that I can give you an idea. Let's say we are shooting a bomb into a target, or let's say we have shot a firecracker into the sky. That's an easier example. So whenever we're shooting a firecracker into the sky by its exhaust system, it is rising up pretty high up. So in that journey, chemical energy of the chemicals, which is producing the gas at a very high speed down the bottom, that chemical energy will be slowly, portion of the chemical energy will be transferred to the firecracker as kinetic energy. Why am I saying portion? Because the firecracker will essentially rise to atmosphere. As it rises to atmosphere, air resistance is going to take out some amount of energy from the firecracker, and as a result, as it keeps on rising, you have all the kinetic chemical energy of the combustible stuffs would not be transferred as GP. There would be somewhat less. At pretty much close to its highest point, that's how it's pretty much usually designed, or somewhere, or if it doesn't happen, let's say it has rise to a certain height, and beyond at that height, let's say the object was still moving, and let's say then the firecracker actually pops. So when the firecracker will actually pop, it will produce a very vigorous reaction of substances, of chemicals, that will liberate huge amount of chemical energy in the form of kinetic energy of the scattered particles. You see, this is also something we call collision. This type of collision is specifically named explosion. Explosion is the case of scenarios where the final velocities of where the final kinetic energy of the colliding bodies is somewhat bigger compared to the initial kinetic energy of the colliding bodies. So in case of explosions, the total kinetic energy after collision might be somewhat bigger compared to the total kinetic energy before the collision. If this example is a bit difficult for you to comprehend, let me put this example in a much simpler form. Disregard the case of skyrocket. Consider a very simple firecracker placed on the ground. You just ignited it and you're waiting. So whenever the wick eventually burns out and eventually the fire gets into the actual combustible chamber with gets into contact with all the chemicals, that firecracker breaks up. So before the pop of the firecracker, that explosion of the firecracker is essentially what we define as collision, because it is within that time the individual segments of the firecracker would push onto each other. So they will exert force onto each other and eventually shoot out in all directions. So before that explosion occurred, the total kinetic energy of the firecracker was 0. After the explosion happens, all the individual particles have a pretty high speed shooting in all directions. So the total kinetic energy has got increased. So that can also be a scenario for cases that where kinetic energy of the colliding bodies could possibly increase. So these are different type of variations. However, the type of collisions where kinetic energy remains conserved is extremely rare to obtain in a physical world around us. But I can give you a hypothetical idea for an example where the total kinetic energy can be constant. You could have studied the Geiger-Marsden experiment in your O-levels, right? In the radioactivity chapter, Geiger-Marsden experiment, where high-speed alpha particles were shot into a very thin gold foil. Recall this experiment?
Yes, sir.
Yes. So,
where the alpha particle deviates after.
Exactly. Most of them went straight through. Some did deviation. Very few bounced back to the same side. Okay. I'm not going into the analysis of that part, but what I need to understand, let's say if you consider a certain alpha particle which happened to start its journey directly at a nucleus of the gold foil. Now try to visualize. Let's say on your left side there is a stationary gold nucleus, which is the center of the gold atom, and from the right side comes the high energetic alpha particle. Now the gold nucleus is positively charged, alpha particle is also positively charged, so essentially they're going to start repelling each other. The closer the alpha particle gets, stronger becomes the repulsion. Why does it become stronger? That is not being covered in your syllabus, but that will be covered in your A2 syllabus, so don't worry. Simple point, you have to remember, understand that the force that exists between the two objects, one of them is the gold nucleus, the other one is the alpha particle, that force is outwards because they are both similar charges. As a result, they will repel onto each other. So as the alpha particle slowly approaches closer and closer and closer, further closer to the gold nucleus, slowly but surely it will decelerate. In this case, deceleration would mean speed will decrease, which would essentially make the kinetic energy of the gold nucleus become less. Now, because energy can be converted or destroyed, this kinetic energy will be stored within that alpha particle as potential energy. We call this potential energy electrostatic potential energy, because the force that is working over here is electrostatic force. The type of force that exists between charged particles is what we call electrostatic force. So as the alpha particle gets closer and closer and closer, it will gain more and more electrostatic energy, and as a result, the kinetic energy will decrease. Let's say the alpha particle does not essentially touch the gold nucleus; it gets pretty close, quite close, and then bounced off back into the same direction. So here we are having a collision. This is also defined as a collision, where the collision did not essentially incorporate physical touch. Both the alpha particle and the gold nucleus did not touch. At the instant, alpha particle swapped back its direction and start moving in the reverse direction. So they did not touch. Because they doesn't touch, this essentially means that there would not be any type of energy loss, somewhat, for the example, for friction or heat generation. So bottom line, as the alpha particle approaches the gold nucleus, Ke converts to EP, and then it will eventually stop at somewhat distance from the gold nucleus, and then it will be shot back into its original direction. And in that scenario, the potential energy that got stored in the alpha particle will once again start to convert into kinetic energy. So this is a very hypothetical case. This is one of the very few cases that I can logically explain and make sense to the kids that I've come across, which can be an actual practical example of elastic collision. Elastic collision means depending on the kinetic energy content, we can divide the collisions into two types, depending upon the kinetic energy content after the collision. Logic to khayal karo. Depending on the kinetic energy conversion, kinetic energy remaining after the collision, collisions are primarily of two types. Number one is that the first one is what we call an elastic collision. Elastic collision means the total kinetic energy before collision equals to total kinetic energy after collision. So for the case of collisions where kinetic energy will be conserved, we call them elastic collisions, and vice versa for cases where the kinetic energy would not be conserved. Not be conserved means total initial is not equals to total final. Total final ta total initial chete choto hote pare. Example, tennis ball bouncing off the ground. But total final kinetic energy, initial kinetic energy se boro hote pare. Example, firecracker or any type of cracker which releases the chemical energy into kinetic energy form in the process of the collision. So basic two types. Depending on how much kinetic energy is remaining after the collision, we have two types of collisions. One is the elastic collision, where the total kinetic energy before collision equals to total kinetic energy after collision. So you might wonder, so kinetic energy likha lagbe? The answer is exclusively yes. You have to write the word kinetic energy because as you can see in the note that total energy of the colliding bodies in a collision, that will by default remain constant. Total energy will never become something else because we are not dealing with the scenario of fusion. So total energy is a constant, which means what? Hello, Lawan, tuma aso?
Yes, sir.
Acha. Total kinetic energy of the total kinetic energy of the alpha particle or alpha particle is the definition of it. So I'm now once again I'm telling you the definition of elastic collision. For collisions where the total kinetic energy of the colliding particles is equal to the total kinetic energy of the colliding particles before and after collision is an elastic collision. Whereas inelastic collisions are those where the total kinetic energy of the colliding particles is unequal or they are not the same as wording. You're going to use any type of wording that you are comfortable with. Total kinetic energy of the colliding particles before collision is not equal to total kinetic energy of the colliding particles after the collision. If that's the case, we call them inelastic collisions. So basically two types. And now you might wonder that what kind of questions might we come across this? Now there are different type of questions over here. One of the easy type of questions that we come across is that we usually are given some sort of data, and we are asked, mostly in the MCQ parts, we're asked that to determine whether this collision is elastic or inelastic. Now, to find that out, our logical process is supposed to be this equation. Mouse over kortesi. So elastic collision is now the half m1 u1 square plus half m2 u2 square. You have a look. The basic expression for kinetic energy is what? Half into mass into velocity squared. So if we use that expression, half m1 u1 square is the total kinetic energy of the first particle before collision. Half m2 u2 square is the total kinetic energy of the second particle before collision. So if you sum this up, you get the total kinetic energy of both the particles. Now, for a certain scenario, one of the particles might be considered stationary. In that case, you will place that value to be 0. That is perfectly all right. But if both of them are moving, you have to place both of their values. Mass cannot be 0, so that's without question. So if we want to check whether a certain collision is elastic or inelastic, this is our first choice. I'm saying first because there's obviously a second, that we can calculate the total kinetic energy before collision, and then we can calculate the total kinetic energy after collision. Compare these two numbers. If they happen to be equal, we can declare the collision is elastic. If the numbers are unequal, big or small, doesn't matter, we'll say the collision is inelastic. So that's one way to do this thing. In many cases, having to achieve this calculation of half m1 u1 square plus half m2 u2 square, this is not essentially difficult for you to remember because you are acquainted with the expression of kinetic energy. But in some cases, this can prove to be extremely time consuming because you have to understand that in your AS exam, in the paper 2 exam, you have to answer 60 marks worth of paper, which is a written paper, 60 marks worth of paper in 75 minutes. So you do not really have the luxury of time. So another convenient and acceptable way to check whether a certain collision is elastic or not is to check the relative speed. So I have used the word relative in bracket because in your syllabus they didn't introduce this word, but I personally like this very much because without using the term relative, the idea of speed of approach or speed of separation is sort of difficult for me to pass across. So the other calculation that we can do is that we can check how much is the relative speed between the two particles before collision, which we call speed of approach. Try to understand. Before collisions, the distance between the two particles have to decrease. Before collision, the distance between the two particles have to decrease, which essentially mean that these two particles would ultimately collide after traveling some time or after some time. Whereas after the collision, the particles should separate out. So this is why before collision we use the term speed of approach, relative speed of approach, and after collision we use the term relative speed of separation. In this case, you just have to logically subtract velocities. You just have to logically subtract velocities. Have a look. এখানে আমরা কি বলছি? Speed বলছি না? What is the term that we are using? We are using relative speed. Did we use velocity?
No, sir.
We did not use velocity. So the calculation answer should have no sign, but whatever the numbers that you're going to work by, they should have sign. What I'm trying to say is that to find out the relative speed of approach, we have to first find out the relative velocity with respect to each other, then make it speed. You cannot make speed and separate them to get relative speed. That would be wrong. So first do a vector calculation of the initial velocities of the two particles, then convert the delta velocity into delta speed. That is the appropriate way. The wrong way is convert each of the individual velocities into speeds, get rid of the direction, and then doing the subtraction. That is the wrong way. So don't do that mess up. First you find out the relative velocity, and then if you get rid of the sign to get relative speed. এটা বুঝার কিছু এক্সাম্পল আছে আমাদের পরের পেজে। I hope let me show you. আছে কি? হ্যাঁ, নাই তো? আছে? নাই। আচ্ছা, let me show you a couple of examples for this paragraph. So have a look at the MS Paint. Let's say before collision, this particle 1, this particle 2. Let's say before collision, this one is going at U1 and this one going in the same direction as U2. So obviously our U1 should be bigger than U2. Now have a look. Both of them are going in the same direction, so I can consider both of them to have the same sign. For convenience, let's assume that is positive sign. In this case, relative speed of approach. So I can write velocity of approach হবে হচ্ছে U1 minus U2. If you wonder U1 minus U2 কেন? Because you need to understand between these two quantities which one is supposed to be bigger. Between U1 and U2, which one is supposed to be bigger?
U1.
For the collision to happen, U1 has to be bigger than U2. So that's our choice. And then you get this number. Alternately, another thing, I'm not showing you what is going to happen after the collision. I'm showing you another version of before collision once again. Let's say in another case, if it so happened that before collision, this particle was going in this direction at 15 meters per second, and this one was coming towards this one as, let's say, 5 meters per second. So I'm not using signs over here. If you're trying to find out the relative speed between each other, you need to really consider that what you're going to do. What I need to consider that if you consider towards right as a positive velocity, towards left must be used as a negative velocity. So আমাদের এখানে কি বলে velocity, or I can write delta velocity of velocity of approach. Delta velocity of approach কত হবে? That should be 15 minus 5. This is the important bit. You can either do this. What is the number that you get? 20. Alternately, you can also do this. Minus 5 minus 15. What do you get? Minus 20. So you have to consider their signs as you do this step. Ultimately, your number should be exactly the same if you don't mess up. And we are interested in this number. So if this number is, so this is the number that we call relative speed of approach. And in the same way, we can calculate the relative speed of separation after the collision. If this difference, relative speed of approach, is equal to relative speed of separation, then also we can directly declare that this collision is elastic. Now, one thing you might wonder that এই লজিকটা আসলো কোথা থেকে, out of nowhere pop করতেছে. Well, in your syllabus, the derivation of this equation or the convincing steps why this equation works is not included. So I'm not going to bother to show you that one, but if you are interested, I could direct you to some internet-based lecture or some other book scan copies to show you how this thing actually came into existence. I can, but I'm not going to discuss that in class because it is not a part of our syllabus. So that's the idea. One of the beautiful things for this second mechanism to check whether a collision is elastic or inelastic, one of the most beautiful part of it is that this equation, for this checking to happen, the mass of the two correlating bodies are out of question. The mass of the two correlating bodies are out of question. আমি কি তোমাদের এটা অলরেডি দেখাবো, আচ্ছা ঠিক আছে দেখাই, সমস্যা নেই, এটা দেখানো অ্যাকচুয়ালি ডিফিকাল্ট না, সো why hold your questions. So I'm trying to show you over here what is not in our syllabus is that where did this equation come from. খেয়াল করো, half m1 u1 square plus half m2 u2 square equals to কি ছিল, half m1 v1 square plus half m2 v2 square. ঠিক আছে কিনা? This is the kinetic energy equation to check whether the collision is supposed to be elastic. যদি এটা হয় তাহলে elastic হবে, এটা যদি ইকুয়াল না তাহলে elastic হবে না. So let's change sides and do the math. So half m1 into, let's say, u1 square minus v1 square. So I took this one on this side, I'm going to take this one on the other side, equals to half m2 u2 square, না u2 square না, ভুল লিখছি, v2 square minus u2 square. আচ্ছা, এখন এই ইকুয়েশনটা এইটুকু পার্ট থেকে লজিক্যালি অনেকগুলো, now what I can essentially write over here is that this one should be equals to what, half m1 u1 plus v1 into u1 minus v1, similarly equals to হবে হচ্ছে half m2 v2 plus u2 into v2 minus u2. এই এক্সপ্রেশন আসবে by the use of some appropriate logic. এটা কি জানো কি ছিল, u1 minus v1 ছিল না? হ্যাঁ, by the use of some appropriate logic we can get rid of this whole part. No, can we? No, we cannot. এটা জানি কেমনে করে আমি ভুলে গেছি, দাঁড়াও বলতেছি। Oh, sorry, ভুল লিখছি। By the use of some appropriate logic we can get rid of this part and this part with this part and this part. By some logic we can get rid of these two parts. That logic is something that is not in my head right now, so ultimately we'll be left with this much. Let me use red. We'll be left with this expression and this expression. So if we do the side change over here, we'll find out that u1 plus v1 equals to হচ্ছে কত, u2 plus v2. So if you do the side change, you'll get u1 minus u2 equals to v2 minus v1. So এই জিনিসটা হয়. So just to make this speed, we have introduced some modulus on both sides. So this is how the equation comes into existence. So I couldn't give you the logic how the half m1 and half m2, half f to কাটা চলে যায়. How could we convert m1 into u1 minus v1 into m1 into v2 minus v2? It actually possible মনে হয়. Possible না? হ্যাঁ, possible. Hold on, can someone tell me how is it possible to get rid of this and this with this one and this one? Can someone guess? Kids, are you even following me?
Yes, sir.
I mean, এটা একটা proof দেখাই. Do you guys remember that Newton's third law tells us that in the collision the f1 equals to minus f2? এটা মনে আছে কারো? f1 equals to minus f2. I can write delta p1 divided by t equals to delta p2 divided by t minus t bad. Therefore, we're gonna get m1 into v1 minus u1 equals to m2 into v2 minus u2. দেখো এটা ঠিক আছে কিনা?
Yes, sir. Yes.
So এটা হচ্ছে আমাদের একটা বেসিক ইকুয়েশন। সো এই ইকুয়েশন যদি আমরা জাস্ট করি তাহলে এই পুরো জিনিসটা এইটুকুর সাথে সমান হচ্ছে। ওই দেখো আমরা ওই জিনিসটাকে এখানে সাবট্রাক্ট করছি। m1 into u1 minus v1 এখানে লেখা ছিল হচ্ছে আচ্ছা আমি একটু জুম আউট করি m1 into u1 minus v1 এখানে ছিল m1 into v1 minus c1 m2 into v2 minus c2 এখানে ছিল m2 into v minus c2 তার মানে হচ্ছে আলটিমেটলি যদি আমরা এই পুরো জিনিসটাকে যদি আমরা এই কোশ্চেনটাকে সাবট্রাক্ট করি এসেন্সিয়ালি এখানে একটা মাইনাস এন আসার কথা তাই না জাস্ট এখানে কি আসার কথা
minus c.
একটা মাইনাস এন আসার কথা নাও উই আর গেটিং রিড অফ দ্য মাইনাস সাইন বাই হ্যাভিং মডুলাস অন বোথ সাইডস
Oh,
তো এখানে মাইনাস সাইন আসবে ঠিক আছে বাট ম্যাগনিটিউড ওয়াইজ এই দুটো ভ্যালু কি হওয়ার কথা ম্যাগনিটিউড ওয়াইজ সেম হওয়ার কথা এই দুটো যদি ভ্যালু সেম হয় তখন যদি সাবট্রাক্ট করলে তাদের ম্যাগনিটিউড ভ্যালু কি হবে ইকুয়াল হবে সো ওইখান থেকে এই এক্সপ্রেশনটা আসে সো বেসিক্যালি আমরা এখানে যে পার্টটা কাট অফ করছি ওই পার্টটা আসছিল হচ্ছে নিউটনস থার্ড ল থেকে বাট এই ডেরিভেশনটা তোমাদের লাগবে না আমি জাস্ট তোমাদেরকে কনভিন্স করার জন্য দেখালাম জাস্ট টু হ্যাভ এ বেটার আন্ডারস্ট্যান্ডিং অফ দিস লজিক সো because the masses and masses are getting crossed out on both sides this check of mechanism that relative speed of approach is equal to relative speed of separation this checking would not require the involvement of the mass calculation you can only use exclusively the motion parameters namely velocities to come to the decision whether this collision is going to be elastic or inelastic simply the velocity values are good enough for you to check depending on this consideration we have a lot of mcqs which you're going to see in our mcq solution parts so we're going to see that so এটা গেল আরেকটা পার্ট আমি এটার উপর এই আইডিয়াটা বোঝা গেছে কিনা পোলাপান
স্যার এই নিউটনের থার্ড লর পার্টটা কেমনে ইউজ করছেন ওইটা একটু
শিওর f1 equals to minus f2 ফোর্স কে আমরা ডেল্টা p বাই t দিয়ে লিখতে পারি এটা আমরা লাস্ট ক্লাসে দেখাইছিলাম ফোর্স ইকুয়ালস টু হচ্ছে m এ তো m equals to হচ্ছে কি v minus u divided by t ঠিক না তো তুমি যদি m into v করো তাহলে কি আসবে
ও ডেল্টা
এটা তাহলে হচ্ছে m into delta v হয়ে গেল না
জি স্যার
m into delta v মানে কি
Momentum.
ডেল্টা পি
so we use that expression in over here for f1 and over here for f2 because the duration of collision should be same for both of them that's why t1 and t2 doesn't exist the duration of time for which they will exert force onto each other that will be same for both of them that's why I wrote only t not t1 and t2 and it follows down from that point makes sense
yes sir
okay anyone else any questions so far because I'm gonna jump into a actual problem solving regarding this exact problem first so that I can help you any question about this explanation anyone হাত উঠাও কেউ হাত উঠাচ্ছে না
so my question.
wow this is awesome বলুন গতকালকে yesterday I did a pretty amazing job yesterday was our inauguration class for the class 9 batch it was a 2-hour class and I discussed a whole lot of philosophy other than discussing physics because it was the first class that video is uploaded in the playlist class 9 in my YouTube channel if any of you are interested you have enough time to kill you can hear up that lecture you might find something that is useful for you কি জানি দেখাচ্ছিলাম
স্যার প্র্যাকটিক্যাল একটা প্রবলেম সলভ করবেন
oh awesome thank you MCQ তে দেখালে দেখানোর সুবিধা honestly speaking okay so we have reached the collision heading কোশ্চেন নাম্বার 1টা অনেক ভালো একটা কোশ্চেন নাম্বার 1টা আমি আগে বলতেছি না 3 আচ্ছা তোমাদেরকে আরেকটা রুল অফ থাম্ব বলি রুল অফ থাম্ব মানে হচ্ছে মানে সিম্পল বেসিক আইডিয়া which is এখানে একটা জিনিস খেয়াল করো delta p1 equals to minus delta p2 না try to understand this one
Ji sir, ji sir.
delta p1 equals to minus delta p2 combining this expression with this part, we can get one specific idea generated. I'm gonna make you. It's written in the note, but I'm just gonna state it for you, which is whenever two equal mass objects, collide elastically, whenever two equal mass objects collide elastically, their velocities get swapped. Whenever two equal masses collide elastically, their velocities get swapped. What do you mean by the word swapped? What could it possibly mean?
লাইক ফার্স্ট মানে একটা অবজেক্টের ভেলোসিটি আরেকটা অবজেক্টের
Change
ভেলোসিটি
হয়ে যায়।
এক্সচেঞ্জ
Exactly, they will perfectly exchange each other's velocity. এরকম কিছু MCQ আমাদের কোশ্চেনে হয়, but if you can remember this information, it will be very helpful to solve for solving a lot of MCQs. Once again, I'm not sharing you the explanation for the explanation অনেক সহজ, but তারপর আমি তোমাদের explanation দেখাচ্ছি না. Why? I'm not expecting a call right now. Please just a second. It's so sir, I have to pick this call. Sorry, kids. It was so sir. I had to pick this call. So sir is somewhat like for me and so sir are like peas and carrots. Do you guys get that reference?
Yes.
না স্যার
Peas and
sir,
carrots
get
are some of the most combined food cooked by British people who basically made all the proverbs back in the day. এরকম আরো কিছু প্রভাব বলো.
fish and chips,
Fish and chips, exactly. Awesome.
ডাল and ভাত.
Bread and butter.
puchka and dog,
Okay.
tea and biscuit.
So we are improvising, but okay, it makes sense. Acha, we'll get back to the lecture. So এখানে আমরা এই জিনিসটা একটু দেখি। এখানে যে কোশ্চেন, আচ্ছা আমি একটা কোশ্চেন বলে যাই। ফর এক্সাম্পল, let's have a look at question number 1. Two similar spheres, each of mass m and traveling with speed v, are moving towards each other. The spheres have a head-on elastic collision. Head-on what collision? Elastic collision. Important bit, very important bit. Which statement is correct? Now have a look. Both of these objects have a mass of m. Both of those objects have a mass of v, have a velocity of v. They are having elastic collision. So like I said at the very just a bit earlier, that equal mass objects having elastic collision with each other, they'll have the velocity swapped. তার মানে হচ্ছে এটা velocity এটাতে যাবে, this velocity will transfer to this one, and this velocity will transfer to this one. So let's have a look at the questions. The spheres stick together on impact. If the spheres stick together on impact, then the total momentum should be 0. Because if you have a look over here, what is the total momentum of this total system before collision? If you consider this is the positive direction, towards right is the positive direction, this momentum is plus mv. Whereas this momentum is what?
Minus mv.
Minus mv. So total momentum before collision is supposed to be 0. mv plus minus mv. So if they stick together, the total momentum after collision can also be 0, but the kinetic energy will also become 0. But that is not allowed because the question tells you what? They do a head-on elastic collision, which means your kinetic energy cannot reduce. Before collision, how much is the kinetic energy? Think.
mv square. Half mv square.
No, not half mv square, mv square. Total kinetic energy, if you are trying to calculate the total kinetic
plus
energy, you have to add those two things. And because you are squaring the velocity, so that way the vector effect is gone because energy is a scalar quantity. So half mv square plus half mv square. So total kinetic energy before collision is supposed to be mv square. So it is impossible to accept that if the two particles have elastic collision, they will stick together on impact. Because if they stick together, they're going to become stationary. Pretty much like, let's say you are shooting two eggs at each other, they collide with each other and become a single thing.
স্যার এই পিডিএফটা কি দেওয়া আছে মেসেঞ্জারে?
Yes.
আর যদি লেগে যায় তাহলে তো দুটারই k 0 হয়ে যাবে।
হ্যাঁ, that's why A is not acceptable. That's what I'm trying to convince you that why A is not acceptable. Because I should add one more thing. Whenever you solve any MCQ, being able to solve an MCQ properly incorporate 4 steps. You should know why the correct answer is the correct answer and you should be confident about it. You should also know why the other 3 are not your correct answers. Whenever any MCQ is a mathematical MCQ, this second step is not required because in a mathematical MCQ, you take the values, you put them in the equation, logically you get a single numerical answer. You see that answer in your question, you choose that, and rest of them are discarded because they are not their answer. But whenever you have logic-based questions, you have to understand why a certain option is correct. You have to also understand properly why the other 3 are incorrect or not applicable for this case. Because there are certain MCQs in your AS level where there may be multiple correct choices, correct options, but you have to choose the best option applicable for the question given scenario. Correct doesn't essentially mean best. You might have multiple correct options, but you might have to choose the best option for the applicable scenario. We'll discuss about this kind of MCQs. These are very rare, but they do exist. So whenever this type of MCQ pops up, I'll refer to this discussion that we are having right now. So A number bad. Whatever for number B. Total kinetic energy is half mv square. Is this something?
After impact তো বাড়ছে না কমছে আমি জানি না।
Well, if it's elastic collision, if it is elastic collision, get this point. The whole idea of elastic collision is that total kinetic energy will be conserved. Conserved means it should be same as before the collision.
Oh,
so before collision, the kinetic energy was mv square. So essentially, after collision, the kinetic energy has to be also mv square. B apparently is a very correct response. Just to be on the safe side, we'll see C and D as well. What does the C says? The total kinetic energy
before impact is 0.
Which is wrong. So get rid of that. Total momentum is 2mv, which is also wrong because a momentum if you're trying to calculate momentum, you have to use vector sign. So you have to do mv plus minus mv, giving you a total result of 0. You cannot do mv plus mv. That would be highly wrong. So ultimately correct answer কি হচ্ছে?
B.
B is the only correct answer. Beautiful.
স্যার এটা যদি বলতো ইনইলাস্টিক কোলিশন তাহলে এ কারেক্ট আনসার হতো না?
Yes. If the question said inelastic collision, the only correct option would have been A. Because C is wrong, C is dead wrong, D is also dead wrong. So if it was supposed to be inelastic, they might stick together. Yeah, you're correct. Acha. Chat window te বলবান কি জানি লিখতেছে আমি chat I'll have a look at the chat window. Bread and butter. Why do you show force equals to minus force and not k equals to minus k? Oh, acha. Rezwan Nafi. Kinetic energy is a scalar quantity which doesn't have any direction. The absolute value of any scalar quantity can never be negative. Change of a scalar quantity can be negative. Let me elaborate this. Let's say you have 10 taka. This is the idea of loan. The amount of money that you can spend is 10. You cannot spend more. You cannot have an absolute value of money that is minus. Disregard the concept of loan. Then again, let's say you have 10 taka, you spent 2 taka. So how much is the change of your money amount? That will be minus 2 taka. Because the final value is 8, the initial value is 8 and the initial value is 10. So if you find out the change of taka, that will be final minus initial, 8 minus 10, that is minus 2. So the change quantity of a scalar quantity can have negative. Negative means value became less. And positive means value became more. But the absolute value of a certain scalar quantity can never be negative. So kinetic energy can never be negative. Whereas vector quantities, positive and negative, does not represent value. Vector quantities themselves, positive and negative, represent direction. That's why for the case of force and also for the case of momentum, F1 equals to minus F2 or delta P1 equals to minus delta P2. But for the case of kinetic energy, that's not the scenario. Farhan Shah, Razin, বুঝা গেছে? Okay. So that was that one. Number 2 can be achieved. Let's give you a try for number 3. Number 3 time to খেয়াল করি. A ball of mass 2 kg traveling at 8 meters per second strikes a ball of mass of 4 kg traveling at 2 meters per second. Both balls are moving along the same straight line as shown. After collision, both balls move at the same velocity v. So they have a combined final velocity v. What is the magnitude of the velocity v? So the point is that we are going to have do some calculation regarding the momentum calculation. So let's go for it. M1 U1 plus M2 U2 equals to এখানে ইকুয়েশনটা হবে হচ্ছে আমি একটু দেখাই মানে because the two objects are getting joined together, so we are not going to use, because the two objects got joined together, so I'm going to write the equation like this: M1 U1 plus M2 U2 equals to M1 plus M2 into V. That's how I prefer to write this. If you find this difficult to perceive or difficult to remember, no big deal. You can also write this like this: M1V plus M2V. Be my guest, no big deal. But in the very next step, you have to do this one as well. So you can directly write this one, or you can write this one and get back to that one. However, that is easier for you to remember by your brain. It's perfectly all right. So if you use these equations, so let's go ahead and use these values. Someone quote me these values. এটা কত? এটা দিলে তো ওটা হারা যায়, ওটা দিলে এটা হারা যায়, কি করব?
স্যার আমার কাছে ওয়ার্কশিট প্রিন্ট করা আছে।
আমার কাছে ওয়ার্কশিট প্রিন্ট করা আছে, এখন কোন হানে আছে এটা হচ্ছে কথা।
স্যার আমি বলতেছি।
আচ্ছা, actually I could have copied that image and brought it to the paint. আমি আসলে বাকি তো চেষ্টা করতেছে এই জন্য হয়তো দিছে সমস্যা নাই ডোন্ট ওয়ারি সো I'll write don't worry কি জন্য দেখাতে চাইলাম ভ্যালু বসাবো so you place the values over here 2 into 8 plus 4 into 2 we can place both of the 8 and 2 as positive because here the velocities are both to the right. So I usually do the maths considering towards right is positive, so I am going for that expression equals to equals to 2 plus 4. There is a total mass into v. There is a combined velocity. Now solve this one. Check out how much this v become. Everyone use a calculator. Help me
It's
out.
4 meters per second.
4 meters exactly.
Yes, sir.
Beautiful. That's your answer. So this is a numerical answer, so you don't have to bother for the other 3 options. But if it was a conceptual answer, you better look for that value. All right. Let's have a look at this question, number 6. Number 62 দেখো সবাই. Check out this one. In a perfect elastic collision between two atoms, it is always true to say that perfect elastic collision কি কি হবে? The initial velocity of one atom would be the same as the final speed of other atom. The question did not say that these two atoms are identical. Very important. Does the question say that their speeds are identical? I mean, they are identical atoms. The question did not say that. So we should not assume that unless we have to. Just keep this in your mind. So let's have a look.
কি হবে স্যার
দেখতেছি the initial speed of one atom will be the same as the final speed of the other atom. That could have happened if the question said that the atoms are identical.
But it's not.
Because the question doesn't specify that the atoms are identical, because elastic bole dise, it says elastic, so which is good. But if you have to have the velocity swapped so that the speed becomes equal, essentially, you need to have the atoms to be identical. That is not provided in the question, so we cannot assume A is the correct answer. Go for B. The relative speed of approach between the two atoms equals after the relative speed of separation. This is a very basic definition of the perfect elastic collision, so we can go for that. Just to be on the safe side, let's consider C and D. The total momentum must be conserved, but a small amount of the total kinetic energy may be lost in the collision. That is highly unacceptable because the question says that the collision was perfectly elastic collision. In perfectly elastic collisions, there can be no energy loss whatsoever. D, whatever the initial states of motion, neither atom can be stationary after the collision. Whatever the initial states of motion, this is whatever the initial state of motion, neither atoms can be stationary after the collision. I would not say it's a correct answer. Let me tell you why. Okay. This D number question is somewhat related to some very recent year MCQ where they asked us about the possible outcome of a momentum question. Okay, for the timing, skip D number. If you have a printed worksheet, put a question mark on the left of the D option. I'll explain the option D in next class, not now. Bolo.
Sir, is there such a thing as not a perfect elastic collision?
Yeah, in elastic collision, the real collisions that we experience in our regular life. For example, I give you 2 examples: bouncing ball for tennis ball or firecracker. Yes, you were able to say something. I paused you. What was your question? Mashur.
Sir,
Yeah, what was your question? I paused you halfway in the question. What was your question?
আমি বলতে চাইছিলাম যে এখানে বলেছে পারফেক্টলি ইলাস্টিক, সো ইলাস্টিক বললেই তো হয়ে যায়।
Yeah, yes, they could have written only elastic. The word perfectly is not essentially required. That's you can consider that's essentially what redundant. Yes.
Okay, sir.
All right, let's have a look at number 7. in which quantities are conserved in an inelastic collision? Which quantities are conserved in an inelastic collision? Kinetic energy not conserved because it is inelastic. Total energy definitely conserved. Linear momentum definitely conserved. So which is the correct answer?
C.
Nah, C.
C তো বললাম।
Oh, আচ্ছা, my bad. ভালো কোশ্চেন কোথায় আছে? নাম্বার 10 দেখো। Number 10. Everyone, give it a try on your own. Read question number 10 and tell me the answer.
D, sir.
D is the correct response. Are all of us sure about that?
Yes, sir.
Yes, sir.
Why is this one the correct answer?
Because they have equal masses and their velocities will be swapped.
Beautiful. That's exactly what I want to hear. For perfectly elastic collisions, equal mass object collisions makes the velocity swapped. So x gets the velocity of y gets the velocity of x. Hence, D is the correct response. Beautiful. I'm gonna ask you to attempt number 9. The calculation is not very difficult, but I would like to explain some theoretical part after question number 9. Attempt number 9 and give it a try. Take it slow. Read the question. Read the question multiple times if you have to, and then
Sir,
give,
what is the answer of 10?
D. D for Dhaka. মামুন এই একটু কষ্ট করো, তুমি এসি এসি দিছো? এই আমাদের জানলাগুলো অফ করে এসিটা অন করে দাও, তোমার পিছনে টার্ন করে দাও, তাহলে আমার ঠান্ডা কম লাগবে। So number 9, give it a try. See if you can solve it. Solving this question would require multiple steps. Although the mark is only 1, but you cannot answer this question in one step. You have to first find out what is the final velocity of the two combined bodies. So that goes for the exact equation that we have written in the paint it. So you have to first find out this v value, what is the final velocity of the combined body. Then you have to find out the total kinetic energy after the collision. That will be m half into m1 plus m2 into v square. You have to calculate this thing. This is supposed to be your answer. So
Sir, is the answer B?
I am not
12 joules.
I can look up. This is 2.2 question number কত ছিল? 9 না?
জি স্যার।
9 answer হচ্ছে B, yes. সবাই কি হইছে? Are everyone done with this one?
Yes, sir.
Okay, let's give it a try for the next question. Oh, the part that I was trying to tell you is that additional to the math that you have done, please try and calculate what is the total kinetic energy before collision, because I'm asking you. It is not required to solve the problem, but just calculate what is the total kinetic energy before the collision. Now, before the collision বলতে কিন্তু এটা কখনো তুমি combinedly হিসাব করতে পারবে না. You cannot calculate this combinedly. Combinedly means you cannot calculate 2 plus 4 into something squared. You have to calculate the first object more kinetic energy half mv squared, then the second object kinetic energy half mv squared, then you add these two numbers. See how much you get.
18 joules.
18 joules. So what you can see from this equation, from this scenario, is that whenever the two bodies got joined together, the total kinetic energy got reduced by 6 joule. Now there are 3 different ways for the case of combination that we say. A bit earlier I told you that whenever there is an elastic collision, the kinetic energy of the colliding bodies, a portion of the kinetic energy can be converted into heat and there is an optional sound. But whenever multiple objects get combined together, there will always be some elastic energy stored, or you can say there would be always some, yeah, I'd say elastic energy stored, because in the process of joining together, these two objects has to produce some new bonds with each other. Two objects getting joined together, what does it mean? That they have produced some new intermolecular forces among particles which did not exist before the collision. That's the basic idea of joining. Some molecules of the trolley on the left got attached with the some molecules of the trolley on Y. Now, whenever bonds are created, what happens? Energy absorbed or energy received, or energy given up. When bonds are created.
Energy given off.
Really?
Yes, sir. Bond chemistry তে তো এটাই পড়ছি. Bond breaking is exothermic.
Then I messed up somewhere. Okay, rephrase. My bad. Whenever the two objects will join together, they will somehow get deformed.
স্যার ওইটাই তো হওয়ার কথা।
They will somehow get deformed. The easiest example that I can tell you, I mean, just to get, I mean, this is the idea of bond forming. Bond forming na, bond forming. This is the idea of bond formation. Let me give you a different example. Try to visualize one thing. Let's say you have a raw egg in your hand and you drop it onto the ground. What happens? It falls and then splashes. After the splash has finished, does the stuff, gooey stuffs, do they, I mean, after they have stopped. So what essentially happened? How do you describe the energy conversion for this process? Let me tell you step by step and see if you disagree with me at any point. When I was holding the egg somewhat above the ground, the egg had a certain amount of gravitational potential energy, GPE, within itself. As you let go, it falls to atmosphere. Now, let's consider atmospheric resistance is significant, which would not be. It would not be, because egg is a pretty heavy object compared to the density of atmosphere. But still, if you consider, as it falls to the atmosphere, it has to push out some air particles out of its path. So a small portion of the initial GPE would be converted into heat, and it would hit the ground with almost equal amount of GPE as it had in the beginning. So as it hits the ground, it has kinetic energy. The instant it hits the ground, the eggshell cracks, gooey stuff comes out, yolk and the protein, and that they are going to spread around in all directions. So now you are making some permanent deformation of this egg, because once the egg breaks up and everything spreads out, it will not naturally come back to its original shape, would it?
No, sir.
It would not come back to its original shape, which means you have permanently displaced molecules of particles from each other of the egg thing. You have made permanent deformation of the object. Now, whenever we make permanent deformation of an object, we have to spend energy to do that, make that happen. That intermolecular space increase requires energy which is absorbed. So in this process of the raw egg getting broken, all of the kinetic energy that was in the egg, not all of them, because whenever the egg falls and hits on the ground and it makes the breaking process, we hear the cracking of the shell, and we also hear the pop sound for the whole thing to squash out. So portion of the kinetic energy will be converted into sound, and there will be also some heat, because there is always some compression, and also significant portion, I mean largest portion of the kinetic energy that the egg had as it hit the ground would be converted into elastic energy. We use the term elastic energy in this case, representing that we made the energy transferred into the object as we made permanent deformation of the object. So we have to do work onto the molecules of the object to make them highly separated, or we have to increase the separation. So that is called an elastic energy stored within the system. So that's how the energy conversion happens. So my point, and obviously a raw egg would never bounce back. So it is a perfect example for inelastic collision, where all the kinetic energy is converting into some other form, elastic energy in this case. So the reason I'm telling you this example is to give you a very basic idea that all sorts of joining scenarios merging scenarios, stick to stick scenarios, they would essentially do have some of the initial kinetic energy converted to make that permanent displacement. And as a result, for all collision cases, if multiple objects are getting joined, listen to this information very carefully. For all collision cases, if multiple objects get joined together, it will always be inelastic collision. Rule of thumb. In any collision where the objects join together and stick together and move in the same direction simultaneously, that would essentially mean that the collision was inelastic. Some kinetic energy must have been lost so that we could merge these two objects. Does this idea make sense? Kids,
Yes, sir.
if you have confusion, raise your hands or just speak up in the microphone, whatever works for you. I'm looking at the chat window. And we have, do we have the private window open? I mean, how does the chat work? Everyone public, okay. In chat window cases, if you can put the question in the public chat window, prefer to put it that way. You don't have to send me privately. But in some classes, I might actually turn on the private chat, depending on the requirement of the class. Anyway, so the reason I told you all of these stuffs, why did I tell you all these stuffs? Because I just wanted to. Okay, never mind. We'll move on. Oh, no. Number 13. Give it a try. Number 13. Number 13 is a very important question for those of you who are still going to some sort of institution. If they take you online exam, they are very likely gonna put this question number 13 in your MCQ test. It is one of the most favorite questions for the examiners because there are a lot of locations where you can make mess in this question in calculation process. Give it a try. Number 13. In the meantime, I'll do some graffiti.
স্যার অ্যান্সারটা কি ক্ষুধা হবে?
13 आंसर देखिए আমি 13 आंसर হচ্ছে সি
স্যার একটু কোয়েশ্চেনটা বের করে
হ্যাঁ
দিন।
সরি মাই ব্যাড দেখো the other day I came across the historic explanation why catapults were named catapults.
কেন?
Can sir?
Because cats always land on their feet. To prove that they can always do them, I mean, the Greek or Roman, whoever actually did this experiment, they were shooting cats with pulse. Pulse মানে হচ্ছে somewhat of a throwing mechanism. I mean, if you visualize a catapult, that's actually a pulse. because they were doing with cats, it was named catapult, and that name got stuck. Just to check whether every cat can land on their feet, which on all of them did. Weird. How many of you are connected to the channel Smarter Everyday on YouTube? Smarter Everyday. Anyone? I don't think so. If you have time to kill, you can look up videos of this guy, Dustin, in Smarter Everyday. He makes amazing videos. I mean, damn, they're good. And then there is Mark Rober, and then there is Veritasium, and then there is Number File, Three Blue, One Brown, Matt Logger. Love these people.
Frequently watch Three Blue One Brown's videos. They're really good. Live গুলো দেখছিলাম, live করছিল কিছু lockdown में.
Three Blue, One Brown. Which one are you talking about?
কিছুদিন আগে কিছু live করছিল, 8-9 videos.
Yes. He came to live. His lives are essentially very good, but his YouTube channel is also very amazing because it's very orderly, and there is step-by-step progress for multiple specific topics that he discussed. I mean, the way he makes the animation and visualize math, that's just phenomenal.
Yes. I've watched it like কিছু playlist গুলো দেখছিলাম.
অনেক জোস, মানে hands down. কত আসছে 13 আনসার? বলা হইতেছে না।
সি আসছে।
সি ইজ দ্য সাবস্টিটিউট দ্য কারেক্ট আনসার। আচ্ছা, এমন কেউ কি আছে পারো নাই? তাহলে আমি করে দেই। আচ্ছা, আমি করে দিচ্ছি। আগে বলো এখানে ফিল ইন দ্য ব্ল্যাঙ্কস কি হবে?
ঘুম।
ইয়েস, ইউ আর অ্যাবসলিউটলি কারেক্ট। উত্তর সঠিক হয়েছে।
খিদা পায়?
না, ঘুম পায়। খিদা লাগে।
খিদা পায়
না, খিদা লাগে, খিদা পায় না, ঘুম পায়। ঘুম পায়, হাগু ধরে, তারপর হচ্ছে খিদা লাগে, ইত্যাদি ইত্যাদি। So yeah, let me help you solve number 13. So এখানে আমরা খেয়াল করি কি বলছে। A stationary body explodes into two components of masses m and 2m. So this is a case of explosion. So initially the object was considered to be stationary. Question about this is a stationary body explodes into two components of masses m and 2m. The components gain kinetic energy x and y respectively. What is the value of the ratio x and y? So to get the values of x and y, you have to find out their velocities so that you can find out the ratio. Now, important bit, finding out their velocities is directly not very easy. So what I can do, or to be more exact, what I'm gonna do is that I am going to paste this, Okay, so this is the scenario. Let me expand this out. Yes, we have this question, so hopefully no problem. আচ্ছা, হ্যাঁ, ঠিক আছে।
আপনি তো স্প্লিট স্ক্রিন ইউজ করতে পারেন, ইজি।
I actually can, which is a very good idea that you tell me, but the thing is that I have this 21-inch monitor, which pretty much serves my purpose so far. আমি মানে যে কারণে আমি এই ঝামেলাটাতে করতেছি সেটা হচ্ছে I on my hand do not have the printed paper of this one. I can very much look it up in my folders and bring that up. I'm just choosing to be lazy. That's why I'm having this thing. But you're absolutely right. I could use a split string.
স্যার,
Yes.
রেকর্ডিং হচ্ছে?
Yep.
আচ্ছা।
তোমাদের তোমাদের জুম ইন্টারফেসে আমি রেকর্ড করলে বোঝা যায় না? বোঝার কোনো উপায় নাই?
জি স্যার, বোঝা যায়। উপরে রেড
আছে তো রেকর্ডিং।
উপরে একটা ওই যে গোল লাল মাঝখানে রেড কালার ডট আসে।
হ্যাঁ,
এটা তো তোমাদের ওখানে আছে না?
Yes, sir.
হ্যাঁ ঠিক আছে সো
আমার স্ক্রিনে নাই তো।
আচ্ছা তোমার স্ক্রিনকে ডাক্তার দেখাইতে হবে, ডোন্ট ওয়ারি। So let's have a look at this one. I'm just kidding. So let's say this is going to break up into two parts. So just to find out the velocities, let's assume that this particle has a speed of v. Now I'm not going to go through an extensive amount of math. I want you to understand, if this particle has a speed of v, then the total momentum on the left direction should be minus mv, ঠিক না? Logic tells us on the right direction the total momentum should be also how much? mv. Why? Because the particle is to be initially what? Stationary, which means the total momentum sum should be 0. If this is minus mv, that one has to be mv as well,
Yes,
positive mv. Now how much mass do you have here?
2m.
So this speed is supposed to be how much? How much speed over here should give the product of these two things to be mv?
হাফ এমবি হওয়ার কথা না?
Half
ও
v.
না স্যার, হাফ ভি
Half v of it. It is going to be half v or v by 2, because by doing this product I can get this number. So the first thing that I did is that I assumed this velocity, I compared the momentum, and then I calculated this one. So I have expressed the velocities in terms of their speed. So I have found I have found their velocities in terms of v. V is in this case a variable, which is perfectly all right. So if I now go for the calculation, what is very important, student, one of the big mistakes that the students do make is that they misread that what x and what is y. What was x? X is the kinetic energy of which particle? Left one, right? So we're trying to find out x by y. So what is going to be the kinetic energy of this particle? That is pretty simple. Half m v square. What is supposed to be the kinetic energy of the same particle? That should be what? Half into 2m into v by 2 whole square. See if it makes sense.
Yes, sir.
ঠিক আছে? তো তাহলে তুমি এই রেশিওটা তাহলে বাই করো, হাফ বাদ m বাদ, সো v স্কয়ার ডিভাইড v স্কয়ার বাই 4। আর এখানে একটা 2 আছে, আবার এখানে একটা m আর m কাটতেছে, বাট এই 2টা তো রয়ে গেছে। সো আলটিমেটলি কি আসবে? v স্কয়ার ডিভাইডেড বাই 2 into v square by 4, which ultimately gives you 2 by 1. Hence, C is the correct response. দেখো
Sir, এটা v by 2 কেন
ভালো করে
হবে?
দেখো, take a good look from start to beginning, try to get the steps. If you have any confusion, ask me. Yes, Labib.
Sir, এটা v by 2 কেন হবে?
বুঝি নাই।
Velocity-টা v by 2 কেন হবে? 2m mass এর।
Oh, because the total momentum of the object before and after collision should be same. As per the question, the combined body was initially stationary. So this one has an initial velocity of 0 before the explosion. This one also had an initial velocity of 0 before the explosion. So the combined velocity of the object was 0. So combined momentum was also 0. If the initial momentum was 0, then the final momentum has also have to be 0. Combined momentum, that is, not individual. Which means the sum of these two momentum of the left fraction and the right fraction, that should lead to 0. Since I have considered this one as mv, I had to consider it as plus mv, so that if you add these two numbers, how much do you get? Make sense?
Yes, sir.
Labib. Hello, Labib. Okay, no man. From that mv, you can essentially calculate that if the mass is 2m, then the speed is supposed to be v by 2. So এটা আমাদের এখান থেকে এই জিনিসটা আসলো। Okay, this MCQ is done. I'm gonna move on. 15. কোনটা হবে correct answer? 15 এর কারেক্ট আনসার কি হবে? হ্যালো,
হ্যালো,
হ্যাঁ, what should be the correct answer for 15?
স্যার একটু দাঁড়ান।
আমি তো বসেছিলাম।
ওকে, একটু একটু বসেন।
আচ্ছা ঠিক আছে। এই একটু নিয়ে কথা বলার একটা জোশ বার হয়েছে। আমার একটু একটা স্টুডেন্ট আমাকে বলতেছে যে, স্যার আপনার মোবাইল নাম্বারটা একটু দেন, আম্মু কথা বলবে। আমি তারপর তাকে রিপ্লাই দিছি যে, একটু দিলেই হবে। হি ওয়াজ লাইক, হ্যাঁ। Then I gave him the first 5 digits.
স্যার ডি হবে না?
Yeah, the correct response is D. Then I gave him the first 5 digits. Then he was like, স্যার এটা কি করলেন? আমি বললাম একটু দিলাম, তুমি তো একটু চাইলা। দেন তারপর সাথে অনেকক্ষণ ঝামেলা করে আধা ঘন্টা পরে ফুল নাম্বার দিছি, একটু একটু করে।
You monster.
I mean, sometimes I'm in the mood to exploit my chances to bother people. দেখলাম আমি তো স্টুডেন্ট একটা খালি জিফ পাঠাই রিপ্লাই দিতেছিলাম। It's fun. I mean, for those of you who have at least one small sibling in your house, or you have your niece and nephew around, you know how much fun it can get when you have nothing else to do and you just start pinching them slowly and you bother them and they start again.
Sir, I do that with my parents.
ওদেরকে কে কোথায় আমরা?
I am the smallest of my cousin group and among my siblings, so I know what it feels on the lower end. So
আমিও স্যার।
if you want to put it that way, that I'm taking revenge, well, I totally agree with you. But is there anyone to stop me now? No.
কিন্তু স্যার আপনি কিন্তু আমাদেরকে গান গেয়ে আর শোনাই দেন না। ক্লাস 9 কে তো ঠিকই শোনাইছিলেন, আপনাকে 6 মাস ধরে বলতেছি, আপনি আর শোনাই দেন না।
আচ্ছা ঠিক
ইয়েস
আছে।
স্যার, এটা কিন্তু অনেক গায়ে লেগেছে স্যার।
আচ্ছা ঠিক আছে।
জুনিয়ররা সিনিয়রদের চেয়ে বেশি ইম্পর্টেন্ট।
কোনো একদিন যেদিন আমার প্রচন্ড ঘুম পাবে বা হচ্ছে যেদিন ক্লাস করানোর মুড থাকবে না, সেদিন আমরা গান বাজনা করবো, সমস্যা নেই।
ওকে, থ্যাংক ইউ।
No problem. What is the other problem that we can solve? এখানে actually difficult কিছু প্রবলেম ছিল, আমি difficult প্রবলেমগুলো কিছু খুঁজে পাইতেছি না। Why? Number 21. 21. Kids, let me alert you for one of the other things is that whenever you're reading the question, be very careful to read whether they have labeled the U1 and U2 as speed or velocity. Very important. Okay, so I just told you this. So give it a try for number 21. See if you can come to some verdict.
স্যার এটা কিভাবে হয়?
এই ব্রাউজার যেখানে ক্লিক করলে ব্রাউজারটা হয়।
না স্যার, আমি বললাম যে V1 আর
সরি
একসাথে মানে হেড অন কোলাইড করে আবার দুই দিকে কেন উল্টা দিকে কি করে যায়?
এটা হতে পারে, মানে তোমাকে তো এই দুটো অবজেক্টের ম্যাচ কথা বলা নাই। মনে করো এই অবজেক্টটা হচ্ছে একটা লেড বল আর এই অবজেক্টটা মনে করো হচ্ছে প্লাস্টিক বল, হইতেই পারে। Size does not necessarily imply mass unless the question specifies it. Don't assume it to be equal. That's a very big trap. We tend to think that equal size object equal mass. No.
স্যার এটা আনসার কি ডি হবে?
We can check. Number 21. Yes, correct answer is D. D for Dhaka. Kids, everyone, can you agree?
Yes, sir.
Perfectly elastic. So speed
Yes,
of
sir.
approach equals to speed of separation. D is the correct response. আচ্ছা, এই 22 একই রকম কোশ্চেন। 24 নম্বর কোশ্চেনটা স্টার মার্ক করো। Star mark question number 24 and start solving this problem. আচ্ছা না, 24টা স্টার মার্ক করে দরকার ছিল না তো, দরকার ছিল না, সরি ভুল বলছি। 24টা, আচ্ছা 24টাকে করো, 24টা করো, 24টা আমার পরে একটা সাম করার জন্য লাগবে। 24টা স্টার মার্ক না করলে হয়তো, নেভার মাইন্ড, স্টার মার্কস আর নেভার ব্যাড থিং। I mean, yeah. So 24 নাম্বারটা কত হবে?
স্যার এমভি টু দ্য লেফট হবে না?
Oh no.
সি হওয়ার কথা না স্যার?
Oh no. Assign values on your calculation, or do more onto the figure.
The B হবে 2 MB to the left.
Yes. B is supposed to be the correct response. Let me help you why. Have a look at this scenario. Actually, let me select this up and copy this and select bam and copy and paste. Have a look. If you consider for the general process that we go by, that towards right is the positive direction. So before collision, it has a plus mv momentum. So আমাদের momentum initially equals to হচ্ছে plus mv. The question says that it undergoes a perfect elastic collision. So perfect elastic collision হলে after rebound, মানে আমি যদি এখানে এই সেম জিনিসটাকে যদি আমি এখানে কপি পেস্ট করে নিয়ে আসি, ঠিক আছে, after rebound কি হবে? Oops, supposed to copy paste it. What is going to happen after rebound? After rebound his velocity is going to revert, ঠিক না? বললাম বুঝো?
হ্যাঁ
velocity revert হবে না? So আমি velocityটাকে দেখো ম্যাজিক্যালি রিভার্ট করে দিতেছি। So এই কেসে তাহলে আমার এখন নতুন velocityটা হবে কত? আমার নতুন velocityটা হবে হচ্ছে -v, because after the rebound this should be -v. তাহলে momentum final pf should be equals to -mv. এখন তুমি যদি ডেল্টা মোমেন্টাম বের করো, ডেল্টা p equals to হচ্ছে always different, মানে changing momentum is always final minus initial, not big minus small. Difference হচ্ছে big minus small. Change always means final minus initial. So this will be -mv minus plus mv. So how much do we get? -2mv, ঠিক না? And এই -2mv এর এই মাইনাস সাইনটা অ্যাকচুয়ালি কি রিপ্রেজেন্ট করে? ভ্যালু রিপ্রেজেন্ট করে নাকি ডিরেকশন রিপ্রেজেন্ট করে? ডিরেকশন। তার মানে 2mv
ডাইরেকশন
টু দ্য লেফট, ঠিক আছে? তোমাদের কার বাসায় পাখি আছে? আমি পাখি শব্দ শুনতেছিলাম একটু আগে। তোমাদের কার বাসায় পোষা পাখি আছে? কেউ কিছু বলে না।
স্যার আপনার বাসার বাইরেই তো।
না, আমার বাসা বাইরে না। তোমাদের স্টুডেন্টদের কারো বাসায় পাখি শব্দ করতেছিল একটু আগে। I could recognize this because আমাদের চট্টগ্রামের বাসায় অনেকগুলো পাখি আছে। আর ভাই অবশ্য অনেকগুলো বিক্রি করে দিয়েছে কোভিড এর সময়ের জন্য, মানে not to be scared but because the market is becoming small. Okay, 34. এটা সামাক করো। This is an amazing question. You have to think inside out or outside box, or, I mean whatever the appropriate stuff that goes in here. You really have to think about this question. And let me give you a small heads up. You cannot solve this question, although it apparently looks like a mathematical answers. You cannot solve this question with math. You have to solve this with logic. 34. Try. Nothing? Cheese with 5%.
Is it C? Sir,
Hello.
is it C?
Yes, C is the correct response. But how?
I was thinking like either like as soon as we're bounds, it has to change in momentum has to be more than 2 MV. Because it's like the initial momentum is 2 MV to the right. And then it has to be the change in momentum has to be more than minus 2 MV. Right? So and it cannot be 4 MV because that's like elastic হয়ে যেত.
Perfect. Good. That's beautiful logic for the explanation. তোমার নাম কি? আমি তোমার নাম বলতে ভুলে গেছি। আমি
Ifat Zarif.
Give us two very solid logics. For those of you who are thinking about this problem, pause for a moment and listen to me. Have a look. How much is the mass over here?
2M.
So towards right, the momentum is 2 MV, and so it's gonna bound over here, hit over here. And if it was an elastic collision, pretty much like the question of this one, এখানে ছিল এদিকে ছিল কত mv, এদিকে আসছে minus mv, so ultimately হচ্ছে কত 2 mv to the left for elastic collision, that is. So এখানে যদি 2 দিয়ে দিতাম তাহলে এখানে একটা 2 আসতো, তাহলে ultimately এই জিনিসটা কত আসতো minus 4 mv হওয়ার কথা না? If the mass was double, then this entire change of momentum কত হওয়ার কথা ছিল? 4 mv হওয়ার কথা। এই জিনিসটা বুঝতেছো কিনা দেখো। Towards right, initial momentum is plus 2 mv. কই গেল কোশ্চেন? Towards right, the momentum is 2 mv, and then after rebound, the momentum should be something. But the question tells you that the collision is inelastic. Inelastic means what? The total amount of energy should not be conserved. Total amount of energy should not be conserved. This essentially means that this object, as it hits with v speed, will not rebound with v speed. Because if it does rebound with speed v, then the total kinetic energy would be exactly same as before collision. In an inelastic collision, the speed of rebound is supposed to be so that the combined kinetic energy after collision is less than the combined kinetic energy before collision. So because this is an inelastic collision, the rebound velocity cannot be v. It should be somewhat smaller than v. So that it would be half into 2m into smaller than v whole square. So that your kinetic energy after collision should be somewhat smaller than the kinetic energy before collision. এই পার্টটুকু বুঝা আছে কিনা বলো? এই পার্টটুকু বুঝা গেছে যে এখন যেটা বললাম?
Yes, sir.
আচ্ছা, so this is one thing. এখন যদি আমাদের পারফেক্টলি ইলাস্টিক কলিশন হতো, then the total amount of momentum change would have been 4 mv. Then এটা হচ্ছে একটা পার্ট। যেহেতু পারফেক্টলি ইলাস্টিক কলিশন হয় না, ইনইলাস্টিক কলিশন হয়েছে, so the change of momentum should be less than 4 mv. It should be less than 4 mv. That's one part. Second part is that if this particle did not rebound, think if this particle was an egg or a sticky glue or plasticine or Play-Doh, so that you hit it over here, it deforms and then sticks over on the wall or vertically falls down. If it did not rebound at all, in that case your momentum change should be only 2 mv, because that would have been 0 minus 2 mv, that is magnitude wise 2 mv. But that is not the case, because the question says what? The particle rebounds. The particle does undergo rebounds. Do you see that? Because it gets rebound, it means it did come off the wall, which means your final momentum cannot be 0. So the difference of these two momentum cannot be exactly equal to 2 mv. The total change of momentum should be bigger than 2 mv but less than 4 mv. That's the logic that you have to get in your head. If I give you in 2 sentences, because the particle did rebound, the momentum delta momentum, change of momentum, should be somewhat bigger than 2 mv. Logic 1. Logic 2, because the particle underwent inelastic collision, so the initial momentum for this scenario would be bigger and the final momentum should be somewhat smaller, which means your initial momentum being 2 mv, your final momentum cannot be 4 MV. Your final momentum cannot be 2 MV as well. So your total change of momentum cannot be 4 MV. Your total change of momentum should be less than 4 MV. So that's the range. Now between 2 MV and between 4 MV, there is only one answer. What is that?
3 MV.
Kids, between 2 MV and between 4 and 4 MV, what is the only option left? That is 3 MV. That's why you have to choose this one. This equation does not come with any math. For example, a equation, for example, if they put over here 3.5 MV, you have to choose this one. Any value, as far as this exact question is involved, any value that is bigger than 2, less than 4 V, that is perfectly the correct answer. Do we understand? বুঝতে পারো নাকি না বুঝলে বলো. There is another mathematical way which I can show you if you need. Yes, Rajan, it's okay. বুঝছো সবাই এটা? I guess so. Okay, number 36. Another star mark question. Number 36 is, it might as well be the most dumb question, or dumb, no, not dumb, I mean this is the question that the students almost in all cases make mistakes at. Number 36. Question that try karo. Try to grab the concept.
A. Sir.
A is the most common wrong response. Correct answer is B.
দরজা খোলা। হ্যাঁ চাচা, বাবা উপরে।
Oh my God.
হ্যাঁ।
তুমি কে ভাই? Anas Islam. Don't do that.
সরি স্যার, আপনাকে বলা হচ্ছে।
আচ্ছা, 36 এর কারেক্ট আনসার হচ্ছে বি। মোস্ট কমন রং আনসার হচ্ছে এ। কোশ্চেন ইজ ওয়াই। সবাই কোশ্চেনটা পড়ছো? Everyone, did you read the question?
Yes, sir, Raj.
Yes,
Question,
sir.
I mean, does the setup of the question make sense? That what is happening? The trolley was incoming with some speed. At the X point, we started adding sand onto the trolley, and at the Y point, a trapdoor at the bottom of the trolley was open, and sand started to fall down. So how does the velocity will change at position X compared to the earlier, and at position Y compared to the earlier? Now, let me tell you.
এটার आंसर কি B হবে?
এটা কারেক্ট আনসার বি হবে। B for বাংলাদেশ।
Does it say this, like, does the velocity stay the same because like sand is
exactly.
gaining some momentum?
Exactly, that's what I'm about to discuss. I mean, do we all agree on the fact that as we add sand on the incoming object, it's gonna slow down? I mean, do we all agree on the first column decreases? এটা নিয়ে কার কোনো কনফিউশন থাকলে বলো আগে, first of all.
না স্যার, কোনো কনফিউশন নেই।
That is perfectly doable. Okay. For the second part, what I need to understand, I mean, I want you to visualize one scenario. Try to think there is a train with only one bogie. There is the engine and there is one rail car. The train is moving and the bogie is moving as well. Let's say at one point of its motion, the latch between the engine and the bogie disconnects. the latch between the train and the bogie disconnects. How will the speed of the two things now change? Do you even get my question?
Yes, sir.
এই কোশ্চেন আমার এখানে আছে, আমি যেহেতু আলাপে করতেছি যেটা in the worksheet থেকে তোমাদের দেখায়, I believe this question is here with us somewhere. Can't find it. কই গেল এটা? এই যে তোমার গান শুনে ফেললা।
স্যার এটা কিছুই ছিল না।
না
এরকম করো কেন? তোমরা না ভালো।
আপনাকে চাইলে একই কোয়েশ্চেন জিজ্ঞেস করতে পারি, আপনি এমন করেন কেন?
আমি তো তোমাদের এখনো ক্লাস টেস্ট দিই না, আমি তো ভালো। Devilish laugh fading in the back. এই বলো, কোশ্চেন নাম্বার 89, এটা আনসার কি হবে? ও লেভেলের কোশ্চেন পড়ো, কোশ্চেন নাম্বার 89 পড়ো জলদি।
স্যার পড়েছিলাম তো আগে।
হ্যাঁ, এটা কারেক্ট আনসার কি হবে বলো? এইটি নাইনের কারেক্ট রেসপন্সটা কি হওয়ার কথা?
Engine speeds up, truck slows down. So B.
Exactly, that is the correct answer. But do you understand why?
Because driving force constant, কিন্তু এই লিঙ্কটা খুলে যাওয়ার কারণে তো মানে মানে
কমে গেছে।
ফোর্সটা কম দেওয়া
That's কমে গেছে।
I need
Mass
more
decreases.
specific হচ্ছে না। Let's say this question, exact question was given, and you are given a state and explain what happens to the speed of the train, speed of the engine and truck after the link breaks. 3 mark. এই কোশ্চেন আনসার কিভাবে লিখবা? Try to give me this answer. স্ট্রাকচার কোশ্চেন মনে করো এক্স্যাক্টলি সেম কোশ্চেন আসলো, তোমাকে স্টেট এন্ড এক্সপ্লেইন করতে বললো, হাউ আর ইউ গোইং টু, হোয়াট আর দ্য লজিক্স ইউ গোনা গিভ মি?
The force stays constant.
But mass decrease করে, so less force required to move.
So if acceleration,
হ্যাঁ, increase করে।
yeah.
Okay, but
For constant force, acceleration is inversely proportional to the mass.
okay,
So যেহেতু they are separating, so individual massটা কমে যাবে and acceleration মানে ইঞ্জিনের জন্য acceleration তখন বেড়ে যাবে।
আচ্ছা ঠিক আছে, that's for the engine part, which all of you agree, and this কি তোমার নাম কি? Ridwan articulated it in my preferred version, which is good one. So that's okay, that's for the engine. What happens for the truck? How do they go explain for the truck?
Friction.
So
The truck slows down due to
friction.
Is friction not
it
applicable
slows
to
down.
engine?
ট্রাকের জন্য তো আর ফরওয়ার্ড ফোর্স নাই কোনো, সো
ইঞ্জিন তো পুল করছে না, সো এজন্য স্লো
Okay,
ডাউন
so
করে।
you have exactly. So you are bringing down the idea of friction for the case of the truck, but you did not at all, even one person mentioned the idea of friction while you are trying to describe the speeding up of the truck of the engine. Why is that? does the engine not experience friction? If the truck experience friction, does the engine not experience friction? My question.
Yes, sir, it does experience.
Yes, sir, it does. It
It
does.
does experience friction.
But
So I can help you to understand this question in a different way. Try to understand. Let's say, just for the sake of simplicity, let's say that the friction experienced by both the engine and the truck are equal. Equal to what? Now, let's say unequal dhori. Let's say the engine experiences 10 Newton of friction force and the truck experiences 5 Newton of friction force. Just try to keep these numbers in your head. Engine experiences a friction of 10 Newton and the truck experiences a friction of 5 Newton. So total frictional force was 50 Newton in the backward direction. So to maintain constant speed, as per the question says, an engine pulls a truck at constant speed. To maintain constant speed, the total forward force that the engine was producing was also 50 Newton. The entire setup is going forward with a constant speed, which is okay. The instance the link breaks down, all the forward force that it is their name ki?
Sir, কি বললেন?
Acha, if you consider the effect of the friction, I mean, I told you that the frictional values were 10 Newton and 5 Newton, right? Now, whenever the link is gonna, so it means that that engine was responsible to produce all of this 50 Newton, part of it for its own self and the remaining part for the truck. Now, when the link breaks down, there is no more contact, no more communication, or no more physical connection between the engine and the truck. So what's gonna happen? The train is gonna still keep on producing force at 50 Newton, but its personal reverse জিনিস কি? দাঁড়াও, আমি আবার বলতেছি, আমি পেঁচাই ফেলছি একটু। Sorry, I'll say this again. The engine now produces a total amount of force of 50 Newton, from which 10 Newton is cut off due to friction. So it now has a 5 Newton of forward force, which that's why its speed increases. Whereas for the truck, it is not connected to the train engine anymore because the link got broken. So it now only experiences friction. So it is a moving body which was initially going to the left. Now the only force that it experiences, horizontal force it experiences, is friction. So friction এর জন্য সেটা আমাদের অবজেক্টটা কি করবে? আস্তে আস্তে চলে যেতে থাকবে। So here the idea of friction is very, very, very important for you to understand the concept of this problem, that if this was not a scenario for friction, then this is not supposed to happen. Okay. Now let me give you a secondary scenario. Let's say the track was frictionless. In that scenario, if let's say in that scenario, what should happen the instant the link breaks down? কি হবে? যদি আমাদের ট্র্যাক ফ্রিকশনলেস হয় তাহলে কি হওয়া উচিত? নিউটনস ফার্স্ট ল বলো কেউ একজন। Someone tell me Newton's first law.
If the resultant force is zero, if the resultant force on an object is zero, then it will either remain at a constant it will move in a constant velocity in a straight line, or remain at its state of rest.
Perfect. One. Acha. So what I mean you to understand is that if we do not apply any force on a moving object, it should be capable of maintaining that motion forever. So if you consider this track is frictionless, to maintain constant speed, any of these two objects, whether the engine or the car, they don't have to spend any energy. এই জিনিসটাকে ভালো করে অ্যাপ্রিশিয়েট করো। within a smooth surface তুমি যদি একটা অবজেক্টকে কন্টিনিউয়াসলি মুভ তুমি যদি একবার মোশন দিয়ে ছেড়ে দাও, because it is a smooth surface, it's not going to experience much air resistance, right? It is not going to experience much air resistance. Simple word কি বলে air resistance কথা আমি বলছি, আমি কি বলছিলাম তোমাদেরকে?
ফ্রিকশন নিয়ে বলছেন না স্যার?
এখানে ফ্রিকশন না থাকলে কি হবে?
friction না থাকলে, if the friction is absent in this scenario, the moment the link gets broken, both the car and the car is going to start to accelerate on its own. The car is going to start accelerating on its own, but this the truck, that should be able to maintain same speed in the same direction. Because if it's a frictionless surface, there is no reason for it to have a backward force. If you do not provide him a backward force and you have already taken out your Eid vacation, so কি বলতেছি আমি হারিয়ে বলতেছি। আচ্ছা বলো শোনো, হারিয়ে বলার কারণ হচ্ছে আমার প্রচন্ড ঘুম পাইতেছে, সো আমি একটা সিম্পল প্রবলেম তোমাদেরকে বলে ফেলতে পারতেছি না। Halfway in my sentence, I'm starting to blabber stuffs. This happens and this is very embarrassing. Never mind. শোনো, আমি নেক্সট ক্লাসে তোমাদেরকে এই এমসিকিউ পেপারে আরো কিছু প্রবলেম অ্যাটেম্প করাবো, and then we can go for the first chapter worksheet. But আমি নেক্সট ক্লাসে আমি এমসিকিউ চ্যাপ্টারে আরো কিছু প্রবলেম করব, not only from 2.2, we might as well take a suggestions from for 2.1 and 2.3. কিছু বুঝলা?
জি স্যার।
ঠিক আছে, সো আজকের মতো একটু থাক, আমি একটু পর তোমাদের লেকচার আপ করে দিতেছি। I really can't see, আমি এখন 4 ঘন্টা ঘুমাবো, আবার 7:30 ক্লাস নাও শুরু করব। সো অল দ্য বেস্ট। তোমাদের কাছে ওয়ার্কশিট আছে মেজারমেন্ট চ্যাপ্টারে এবং কাইনেমেটিক্স চ্যাপ্টারে, যেখান থেকে ডাউনলোড করে প্রিন্ট করে যতটুকু পারো অ্যাটেম্প করতে থাকো, ইভেন্চুয়ালি যেতে আমাদের সলিউশন ক্লাসগুলোতে রেসপন্ড করতে পারো। ঠিক আছে?
ওকে স্যার।
আচ্ছা ঠিক আছে। Everyone, thank you very much. Goodbye.
আসসালামু আলাইকুম স্যার।
Thank you, sir.